Here's Leetcode problem 2529, maximum count of positive integer and negative integer. The problem asks us to find the maximum between the count of positive integers and the count of negative integers in a given sorted array. The array is sorted in non-decreasing order, meaning numbers can be equal. Crucially, 0 is considered neither positive nor negative. We're given a few examples to illustrate the expected behavior. The constraints tell us the array can have up to 2,000 elements, and each element falls within the range of negative 2,000 to 2,000. It is also sorted in a non-decreasing order. Here's a brute force solution. We initialize two counters, pos_count and neg_count, to 0. We then iterate through the input array nums. For each number, we check if it's greater than 0. If it is, we increment pos_count. Otherwise, if the number is less than 0, we increment neg_count. Finally, we return the maximum of pos_count and neg_count. Zeros are effectively ignored because they don't satisfy either condition. The time complexity is big O of n, where n is the length of the input array nums, because we iterate through the array once. The space complexity is big O of 1, or constant, because we only use a fixed number of extra variables, pos_count and neg_count, regardless of the input size. Now let's look at a more optimal solution, using binary search. Since the array is sorted, we can use binary search to efficiently find the boundaries between negative, 0, and positive numbers. We define two helper functions, lower_bound and upper_bound. Lower_bound finds the first index where the value is greater than or equal to the target. Upper_bound finds the first index where the value is strictly greater than the target. We use upper_bound, nums 0, to find the first index of a positive number. Subtracting this index from the total length of the array gives us the count of positive numbers. We use lower_bound, nums 0, to find the first index of 0 or a positive number. This index is equal to the number of negative integers. Finally, we return the maximum of pos_count and neg_count. Let's break down the lower_bound function. We initialize left to 0 and right to the last index of the array. The while loop continues as long as left is less than or equal to right. Inside the loop, we calculate the middle index mid. If the element at nums at position mid is less than the target, it means the target must be in the right half, so we update left to mid plus 1. Otherwise, the target might be at mid or in the left half, so we update right to mid, 1. Finally, we return left, which represents the index of the first element, greater than or equal to the target. Now let's look at the upper_bound function. It's very similar to lower_bound. The key difference is in the if condition. If the element at nums at position mid is less than or equal to the target, we update left to mid plus 1, because we're looking for the first element, strictly greater than the target. Otherwise, we update right to mid, 1. We return left, which represents the index of the first element, strictly greater than the target. The time complexity is big O of log n, where n is the length of the input array. This is because we perform two binary searches, each taking logarithmic time. The space complexity is big O of 1, or constant, because we use a fixed number of extra variables, regardless of the input size. That's it for Leetcode problem 2529. If you found this helpful, please like, subscribe, and comment below with any other problems you'd like to see in this series. You can also help me continue making videos by donating at buymeaboba.com. Link in description. Thanks for watching.